Hi, my name is Jim Ranchler, and this is the second video for my baseball game. So I'm making this baseball game for my video game physics class. And what I'm going to do is I'm going to go through and I'm going to use baseball as a good example of a physics-based game and just program a very simple game where somebody pitches a ball. So you see the animation panel in the middle is some guy throwing a ball, and some other guy hits the ball. You can see the animation panel on the bottom is some guy hitting a ball with a bat, and we'll do some physics with it. That's pretty much the purpose of this. This is the second video. The first video talked about each of the different things that I'm going to use, and the program flow and things like that. It was the design document for the game, which I scratched out on a piece of paper, both sides. And then the next video I'm going to make is actually going to start programming the game. So I'm going to program the game in order, in the way that I would do it in the class, or to be more precise, in the way that I teach the different subjects in the class. So this is going to be a little bit out of order for how I normally do things, but it will be a fairly logical order. So I'm going to draw things now. I'm going to draw a background. You can see the cross-sectional view of the pitcher's mound and the home plate and the batter's box right there. And you can obviously have got the animation things. I'm going to turn the animation into stick figures for now. At the very end of the course, at the very end of this video series, I'll use my little animation strips. But first I'm just going to use the pie game drawing things, the drawing methods to draw things. This is really to get students used to positions and other sorts of things. So Unit 1 is usually position and time, and we just deal with drawing static things on the screen, and we deal with time, and we deal with buttons and states and things like that. Really just to get students used to how to interact with things on the screen, how to draw things on the screen, and how to deal with time. And then we get into the physics, we get into the mechanics where we're actually moving things around on the screen. That's not what we're going to do right now. We're just going to start drawing. Well, that is what we're going to do right now, is we're going to draw things on the screen. So I'll just start, right? And so here I've got a aerial view or a plan view of the region of the baseball field, the baseball diamond that I really care about. And that's really home plate with the batter's boxes to either side and the pitcher's mound. Fairly simple. When I do this in class, I have the students draw out a soccer pitch instead, because it takes a little bit more time. It takes about a full period to actually figure out the coordinates, and takes another full period to program in the coordinates, and the students get a lot of work with that in drawing out the background and a little bit of work with color and things like that. So that'll be good. But this isn't what I want to do in this case. I want to look at the cross-sectional view or the side view of the plane area. So this is what the cross-sectional view will look like. I've got some things on the left-hand side that you wouldn't probably see. You know, if you just took a giant saw and you cut a baseball diamond in half, along this diagonal, you probably wouldn't see the plate sticking out like that, and you definitely wouldn't see the batter's box. So it's a little bit different than what you actually see. Some things are just there to suggest things are representational. That's fine. It's a game, right? So let's just see what we do. So what do we do? What do I need to do? I need to figure out how to get this into the game, right? And how do I get this into the game? I have to know the actual dimensions of the baseball diamond. And I did this myself by looking things up on Wikipedia. I also have a handout that I didn't have with me, so I looked it up on Wikipedia, right? So the batter's box is 6 foot wide. Home plate is 1.5 feet long. And the pitcher's mound is 18 feet wide and 0.83 feet tall. Right? Those are coordinates that I'm going to need to actually draw this thing. I'm also going to need to know how long the entire length of the field is, which means I have to know exactly the distance between home plate and the pitcher's mound, Major League Baseball was kind enough to make a specification for that. That's 60 feet and 6 inches. Now I add 9 feet, half of the pitcher's mound and half of the plate, or of the batter's box, excuse me. And bam, I've got 72 feet 6 inches as the entire length of the screen when I write the program. All right, so that's one number I'm going to need. There are 3 other numbers that I'm going to need here. I'm going to, and those are vector numbers, so they're 2 coordinates. So 3 other pairs of, and I guess I need length and width, so that's 6 pairs of coordinates that I need. For the pitcher's mound, that's going to be the upper left-hand corner of this rectangle that's inscribed. Maybe you can see that. You can see probably these little corners that PowerPoint is making for me. Well, this guy right here is the guy that I care about. So I need to figure out what that is, and I need to figure out the same corner of the rectangles, although that's not such a weird idea because it's an actual upper left-hand corner of the rectangle, not the upper left-hand corner of the rectangle that inscribes an ellipse that the arc is on, or whatever that is. I think that sufficiently describes what I need. So this is the hard one. The mound is the hard one. But it's not that hard. All I have to do is a little bit of this arithmetic stuff. And so I take 72.5 feet, I subtract 18 feet, that's the x-coordinate, that's 54 feet 6 inches, 54.5 feet, and the upper left-hand corner is just going to be this 0.83 feet tall. The length and width is 18 feet plus twice, 0.83, so 1.66 feet, 1 2/3 feet, I guess. Pretty simple. I think you can handle that sort of arithmetic by now. On top of that, I want to do stuff with home plate and with the batter's box. The batter's box is 0 and a little bit below that line. It's not really going to matter how much. We'll make that up as we go along. And it's going to be 6 feet wide and something short down. So we don't want to use the full 4 feet for that. It's just representational, so I'll use 2 feet or 1 feet or something like that when we get to it. Again, the height of the plate, that doesn't really matter. It'll be something like half a foot or something when I draw it out. But the left-hand corner is important, right? And that's going to have to be something that's going to be half the width of the batter's box, which is the center of the batter's box, which is also the center of home plate, minus half of the length of home plate, which is 1.4 feet, which is 0.7 feet. So we have 3 minus 0.7 feet, and that's the x-coordinate of 2.3 feet. That's the sort of reasoning you have to do. And you can do that for this sort of thing quite easily. It's going to be a little more complicated when we get to this guy, right? Now for this guy, again, I only want to draw the pitcher waiting. I will draw the rest of them when it's time, but I want to say how to draw just one. You'll notice how long it's been just explaining the pitcher's mound. This guy's going to be a little bit more. Excuse me. So I don't want to do any of these other guys here. I just want to do this one. To do that, I'm going to want to put together a grid. You'll notice the grid is in blue. There are some slightly thicker lines here and here which come to the center of the guy, which is where we're going to say the object is. All of our objects are going to be more or less at their center. Now this is a wide thing, but that's just because the pitcher's going to extend as he draws. But we're not really going to do anything with changing the position of the pitcher. The pitcher is going to just have one spot, which is going to be the center of the pitcher when he's just standing. That might not be the most useful for this particular application, but it will be quite useful for most of our applications, because mostly we're going to be drawing squares and rectangles doing their thing. We're not going to spend a lot of time drawing really cool stuff, unfortunately, but fortunately, because I've seen how much the students love doing that, drawing things from scratch. You'll also notice that this guy is about 1 unit tall. He goes from minus 0.4 down to 0.6. You also notice, so that's about 1 unit tall. That way I can scale the guy, I can scale the picture by however high he is. That way I can use the same class to represent a 6 foot tall pitcher, or a 5 foot tall pitcher, or a 6'5" pitcher, whatever I want, right? Just one of these guys like this, I can make him larger or smaller, not an issue. That's basically what this is for. You'll notice that the numbering goes down. This is because this is what people do in computers. They use that upper left-hand corner as 0, and then they go downwards. We're going to use the center as our origin, but eventually we'll have to relate it to the upper left-hand corner of the screen, wherever that happens to be. So this is how we're going to do that. I mean, we could do it the other way, but that would just leave one more place where you can have an error. Although it would be an easy error to figure out, because whenever you had your pitcher standing on his head, you'd know not only that you did something wrong, you'd know what you did wrong, right? So it should be fairly easy to correct. And you remember that when you're programming, just correct it. I mean, don't worry about it, just correct it. Figure out what's wrong and fix it. So that's what we've got. Now we have to make our drawing. Well, our drawing is just going to be a stick figure like that. It's not easy to see, so I'll get rid of the regular picture, and bam, you've got a stick figure picture. Looks pretty reasonable as far as stick figure pictures are concerned. I've seen a few pictures that were a little less meaty than this, but not many. And now what I'm going to do is I'm going to use that coordinate graph to figure out where each of these points is. Actually, what I did was I printed out the previous pictures, and I drew circles and stuff and figured it out on paper first. And now you're just going to get the results. So if it sounds like it's going fast, it's because it is, and because my free screen casting program stops at 15 minutes. And for some reason, I can't stop talking for 15 minutes. I'm a professor. As a professor, it's sort of an obligation to talk too much, right? So that's what I'm going to do. Is I'm going to talk too much. I'm going to talk too much for a long, long time. But I'm going to try to stop really soon so that doesn't happen. So what we want to do is we want to figure out stuff like where's the center of that guy's head. Well, it's a little bit to the left, but really let's pretend like it's right dead center at 0, 0. Or at 0.0 is x. It's also halfway in between minus 0.2 and minus 0.4, so we'll say minus 0.3 is its center. And since it's sort of halfway in between and straddling those two numbers, let's give it a radius of 0.1 feet. Those are the numbers that we're going to need. Well, they're not feet. They're percentages, actually. It's 10%. So what we've got here is everything we need to actually draw that particular spot, that circle. We need 2 points for the line, and that's what we've got for the brim. One a little bit farther to the left than the other one. Then we've got another 2 points for the body, 2 points for the shoulders, another point from the shoulder to the elbow, and one to somewhere in the center of the mitt. That sounds pretty good to me. After that, we need to draw the mitt. Again, we need that upper left-hand corner plus the width and the height. These are the numbers that I got. You'll have to live with that because I'm running out of time. And once you do that, I'll show you how to do that in just a few videos. And then we have a few more points here and there that we have to fill out. Now we've got a whole bunch of points. We're all ready to take all of these points and turn them into an actual animation. So we're pretty close to where we need to be. So these are the things that we're going to want to turn into animations, and I've just shown you how we're going to do that. And the very next time I start recording, I'm going to be recording me working on this guy here on the background. All right? Thank you very much, and I'll see you soon.